Good morning, Doc. Good morning, teacher. So today I am going to discuss about matrix multiplication. Matrix multiplication is also known as matrix product. A matrix is a rectangular arrangement of numbers into rows and columns. Each number in a matrix is referred to as a matrix element or entry. So the numbers -2, 5, 6, 5, 2, 7 are the matrix element or entry. Dimensions of a matrix give the numbers of rows and columns m by n of the matrix in that order. Since our matrix has 2 rows and 3 columns, then it is a 2 by 3 matrix. Now here are the example of matrix and the size or dimension. So if it has 2 rows and 3 columns, so it is a 2 by 3 matrix. And so on, 2 by 1, 3 by 2, 3 by 4, and 5 by 5 or square matrix. Square matrix is a matrix where rows and columns m by n are equal. So there's an example. 2 rows and 2 columns is a square matrix. Another one is a column matrix, or M, is a matrix made up of just one column and any number of rows. Example in the figure. And another one is row matrix, where a matrix is made up of just one row and any numbers of column. So kahit ilan numbers pa yan, as long as it's a one row, then you call it a row matrix. The same as with column, any number of rows, pero isa lang yung column, then it is a column matrix. In this table, A, B, and C are n by n matrices. I is the n by n identity matrix, and O is the n by n zero matrix. In the properties of matrix multiplication, commutative property does not hold since the product of matrices AB is not equal to BA, which I will give an example to explain the reason why. Another property is the associative property of multiplication, where, example, the product of matrices AB times C is equal to A times the product of matrices B and C. Next, we have distributive property, where, example, A multiplied to matrices, or the sum of matrices B plus C is equal to the product of AB plus AC. Or we could also have B plus C times matrix A is still equal to the product of BA plus CA. Next is multiplicative identity property. So when we say identity, it is the product of a number and itself. That is why I and A is still equal to A, and I and A is still equal to A. Then multiplicative property of 0, where the product of matrix O and A is still equal to O, and product of matrices A and O is still equal to O. Lastly is a dimension property, where the product of M by N and N by K matrix is a M by K matrix. So here is an example why commutative property does not hold in the product of matrix. So example, let A and B be matrices. So if you multiply matrix A and B, the result is 2, 0, 0, 0. Now, if you multiply matrix B and A, the result is there. As you can see, the product of matrices A and B is not equal to the product of matrices of B and A. Therefore, in general, this is not commutative. Now let's move forward to the matrix multiplication condition. Remember that you can only multiply matrices only if the number of columns in the first matrix is equal to the number of rows in the second matrix. Example in the picture. So example, if you have two matrix A and B, so the inner part must be equal and the outer is the size of the product of the matrix. So the condition must be, before multiplying two matrices, we have to take a look that the inner must be equal so that the product will be defined. But if not, then the product is undefined. So let's have another example. If you have noticed our example, we have the inner of 2 and 2. So our inner are equal, so we can proceed to multiplication and our product is defined. In this example as well, we have an outer of 3 and 3. That is why the result gives us a 3 by 3 matrix. So that is our dimension or our size. Now I think we're ready and let's try. Now state whether the product is defined or undefined and the size for matrices A and B. So we have example number 1. So matrix A is 3 by 5 and matrix B is 5 by 4. Since the inner is equal, which is 5, so we can proceed to multiplication and the product is defined. And of course, we have the outer 3 and 4, so the size of our matrix is 3 by 4. Now you can pause the video if you want to try. Now this time we are multiplying matrix with entry. We have scalar multiplication. Now think about distributive properties. So the element of the matrix are multiplied by a value outside of the matrix. So madali lang ang scalar multiplication. So we have example at the bottom. So 5 multiplied to a square matrix which has an element of 8, 23, negative 11, and 16. So the product is, so 5 multiplied to 8, the answer is 40. 5 multiplied to 23, the answer is 115. Then 5 multiplied to negative 11, so negative 55, and 5 multiplied to 16, that gives us an 80. So that is the result of our matrix. Next is multiplying with rows and columns. So before executing the operation again, make sure that the product is defined. So example, so as you can see, same number ang ating rows dito, which is dalawa, and same number ang ating columns dito, which is dalawa din. I will create a video to show the step-by-step process in multiplying matrix with rows and columns. Tada! So example, we have here our problem. So first, kailangan natin i-identify if defined yung product. So let's count. We have 2 rows and 2 columns. So it's a 2 by 2. Next, we have 2 rows and then 2 columns. So still 2 by 2. Now, since we have the same inner, we can now proceed to multiplication kasi equal yung inner natin. First thing natin gawin is to identify our rows and columns. So the process is, we have to multiply the rows to each columns. Same with the second row to every columns. So now let's do the operation. We have first row 1 to column 1. And we have to put it sa column 1 or row 1, column 1. So there you go. 2 times 4, distribute, plus 0 times 5. Next, first column sa second column. So first siya at second column. So ilalagay natin siya sa first row, second column. So 2 times negative 5 plus 0 times 3. So, same process. Next is second row to first column. So ilalagay natin siya dyan sa first column pero second row. So 3 times 4 plus 6 times 5. Next, second row to second column. So dyan natin siya ilalagay. 3 times negative 5 plus 6 times 3. Ayun. There you go. And now we do the operation. Now we solve to simplify. Pero char lang equals sa, there you go. 2 times 4 equals 8 plus 0 times 5 equals 5. Next, second row, then first column. 3 times 4, 12 plus 6 times 5, 30. Next, 2 times negative 5, negative 10 plus 0 times 3. So, 0. Nag-una na siya. So, negative 15 plus 6 times 3, 18. Ayun. Next, i-add na siya. So, 8 plus 0, 8. Wow. 12 plus 30. Wow. Isip pa. 42. Negative 10 plus 0. Ayun. Negative 10. And negative 15 plus 18. Nag-iisip pa. Oh, daw. Char. 3. Ayun. So, there you go. We have our answer. 8, negative 10, 42, and 3. Now, if you notice again, sa outer natin, we have 2 and 2. So, the dimension of our matrix is 2 by 2 matrix. Now, you see? That's the size, and there you go. So, let's check if our answer is correct. 2 daw siya ka row, and 2 daw yung columns. So, there you go. We have the answer of 2 by 2 na matrix. And that's it. That's our final answer. Char! 8, negative 10, 42, and 3. And a size of 2 by 2. There you go. I guess it's time for you to try, so I prepared an exercise, so just pause the video if you want to answer. If you got these answers, then you are doing it right. You could also have this exercise, just pause if you want. I guess that's all for my report for today. Thank you for watching and have a good day, everyone. Thank you.